So today we will be analyzing graphs of polynomial functions. To do this, we're going to do a few different things. We are first going to graph each function by making a table of values. When we have our graph, we're going to determine the consecutive integer values of x between each real zeros located. We're going to estimate x coordinates for relative maxima and minima, and then we are going to determine the domain and range. So the very first thing you want to do is, before you even make the table of values, you want to look at your function and you just want to sketch what it should look like. So this says f of x is equal to x to the fourth plus x to the third minus 4x to the squared minus 4x. So first off, we know that the highest coefficient is 4, which is even, and the leading coefficient is positive. So we start off positive, so that means we start off to the right is up. And then if that's 4, we go 1, 2, 3, 4. So the graph should look like that. Notice that we switch directions for each exponent. So if we had x to the sixth that was positive, it would be 1, 2, 3, 4, 5, 6. If we had x to the third, it would be 1, 2, 3. Alright, so you're going to be taking a look at that to determine what the graph should look like at the end. This way, when you're making the table of values, you'll be able to know kind of when to stop. So we are going to make the table of values. Now, to do this, we can actually use synthetic division because we know that our remainder would be whatever f of 1 is. If we did plugged 1 in, our remainder here is whatever equals. So we're going to be using synthetic division to help us make these tables. And that way we usually won't mess up with some negative signs as well. So here, it's always good to start from -2 to +2. So I'm going to set up synthetic division. So 1, 1, -4, -4, and 0. And now we're going to do the middle step of adding in our head. So here's our remainder column. So this is sort of like our x and like our y when all is said and done. So we'll start from -2 to +2 and just see what we get, see what the graph looks like. So we drop down the 1. Now this time when we multiply, we'll be multiplying the 1 by the -2. We know that's -2, so we envision -2 underneath this 1, and then 1 plus -2 is -1. Repeating the process, -1 times -2 is +2, so okay, -4 plus a +2 is -2. Continuing the process, -2 times -2 is +4, +4 plus -4 is 0. 0 times -2 is 0. 0 plus 0 is 0. So this tells us on our graph we have a point of -2, 0. So we can go graph that point, -2, 0. Alright, now we do -1. Still drop down our 1. Okay, 1 times -1 is -1. 1 plus -1 is 0. 0 times -1 is 0. 0 plus -4 is -4. -4 times -1 is +4. -4 plus +4 is 0. And 0 times -1 is 0. 0 plus 0 is 0. So this also tells us we have the point -1, 0. So there we can go over to our graph and plot -1, 0. Whenever we plug in 0, we can just go straight through because we know all of these will be 0, and we will end up with 0 in this case. We also have 0, 0. Now, we will talk about what to do here when we have these 3 points in a row that are horizontal when we finish this chart. So 1, so we drop the 1 down. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2 plus -4 is -2. -2 times 1 is -2. -2 plus -4 is -6. -6 times 1 is -6. -6 plus 0 is -6. So here we have the point 1, -6. So we can plot that point. there's 1, negative 6. Alright, and the last point here 2, so we drop down the 1. 1 times 2 is 2, plus 1 is 3. 3 times 2 is 6, plus negative 4. Negative 4 plus 6 is 2. 2 times 2 is 4, plus negative 4 is 0. 0 times 2 is 0, plus 0 is 0, so we have the point 2, 0 as well. Now, we need to know what to do with these three values here that are horizontal, because this does not really tell us how this will loop around for our graph. We clearly see that this on the right hand side from 2, 1 to 0 definitely goes down, so that probably corresponds to this first loop. But we need to figure out what goes on here. So anytime you have 3 points that are horizontal like this, we need to try values in between there. So a value in between negative 2 and negative 1 would be something like negative 1.5. We also will need a value in between negative 1 and 0, which would be something like negative 1/2. Right, and then we probably also want to get one more value to the very left of everything, so negative 3. So we're going to plug these three values in as well. So we'll drop the 1 down. 1 times negative 1.5 is negative 1.5, plus 1 is negative 1/2. Negative 1/2 times negative 1.5 is positive 3/4. Positive 3/4 minus 4 is negative 3 1/4. Negative 3 1/4 times negative 1/2 is positive 4 7/8. Positive 4 7/8 plus negative 4 is 7/8. And then here we have 7/8 times negative 1.5 is negative 1 5/16. Negative 1 5/16 plus 0 is negative 1 5/16. This tells us that negative 1.5, so in between the negative 1 and the negative 2, we're down a little bit more than 1. So we have a point right about there. Okay, so now we'll plug in negative 1.5, so we drop down the 1. And then we have 1 times negative 1/2 is negative 1/2, plus 1 is 1/2. Now we have 1/2 times negative 1/2 is negative 1/4. Negative 4 plus negative 1/4 is negative 4 1/4. So we have negative 4 1/4 times negative 1/2. And that gives us positive 2 1/8. So we have negative 4 plus 2 1/8 gives us negative 1 7/8. Then we take negative 1 7/8 times negative 1/2. That gives us a positive 15/16. Plus 0 then gives us a positive 15/16, which is pretty darn close to 1. So here we will now plot the point of negative 1/2 positive 15/16, which is close to 1, not quite there, but close to. And then the very last point, this 3, we're going to plug this one in to see what happens over here on the left-hand side of this graph. So we drop down the 1. 1 times negative 3 is negative 3, plus 1 is negative 2. Negative 2 times negative 3 is a positive 6, plus negative 4 is a positive 2. 2 times negative 3 is a negative 6, plus negative 4 is negative 10. And then negative 10 times negative 3 is a positive 30, plus 0 is a 30. So when we were at here over at negative 3, we were way up at 30. That's way off of our graph. So now we're going to connect this, keeping in mind that our graph should look something like this, and that's what we have. So now we're up here on the right. We're going to go down through these points, connect them, go up, go down, and go back up. So there is our graph. It looks like that sketch. Okay. Obviously the various dips and things are going to be dependent upon what values we have here. So there we graphed it. So now we want to determine our values for x. In this case, we actually know the real zeros. Every time we cross the x-axis here is a real zero, and we know these values exactly. So our real zeros here happen at -2, -1, 0, and 2. Alright, so those are the number of real zeros. We want to estimate for relative max and relative min the x values. So a relative max here is where the graph is going to kind of pop up. So this graph here humps up right here. So that would be a relative max. So relative max would be right up there at that point. And that point we know happened right here when x was -1/2. So the relative max happens at x equals -1/2. The relative mins, then we want to look for the same thing where these dip down. So there's a dip and there's a dip. So these two values here would be relative mins. And those two relative min values, we know one of them was right here at -1/2. So at x equals -1/2. And the other one was right here when x was equal to 1. So that's our relative min and max. And then last but not least, we're going to have to state the domain and range. So when we're stating the domain and range here, we are going to want to figure out what the x values could be, as well as what the y value. So here our domain are whatever our x values can be, and our range are whatever our y values can be. So looking at the graph, the x values can be anything, so x can be in the real numbers. The range though, since we have a minimum value right here, our graph can only be above it, so our range would be y is greater than or equal to, that minimum value was -6, so it has to be greater than or equal to -6. Okay, stay tuned, we'll do another example on the next slide. Now this example, we're going to do the same thing, we're going to graph it. So we're first going to take a look at what our function originally says, and we're going to think about what the sketch looks like. So f of x is equal to x to the third minus 5x squared plus 3x plus 2. Our highest coefficient is 3, with the leading coefficient a positive, so we start up, and then we go 1, 2, 3, so the graph should look something like that. Alright, so we are going to make our table of values, and we'll be setting up our synthetic division to do so. So here we have 1, -5, 3, 2. Once again, the remainder, those are like your y values. Over here are your x values that you're plugging in. And we will start from -2 to +2. That's what we're always going to start with. And then we can adjust from there like we did in that previous example as we need to. So we're going to drop down the 1. 1 times -2 is -2, plus -5 is -7. -7 times -2 is +14, plus 3 is 17. And then we have 17 times -2 is -34, plus 2 is -32. The point we have then is -2, -32. That's way off the graph, so we're not going to graph it. We'll just move on to the next one. Drop down the 1. 1 times -1 is -1, plus -5, so that's -6. -6 times -1 is +6, plus 3, so that's 9. 9 times -1 is -9, plus 2, that's -7. This one is certainly on the graph, so we can plot the point -1, -7. Okay, next one, 0. Well, we know that when we have 0, we just end up getting whatever our last value there was, which was 2 in this case, because when we plug 0 in for the x's, those are just all 0. So we can plot that point of 0, 2. Alright, next value down, we drop down the 1. 1 times 1 is 1, plus negative 5 is negative 4. Negative 4 times 1 is negative 4, plus 3 is negative 1. Negative 1 times positive 1 is negative 1, plus 2 is 1. So this tells us we have the point 1, 1. So we can graph that point 1, 1. Alright, and then we will do our 2. We drop down the 1. 1 times 2 is 2, plus negative 5 is negative 3. Negative 3 times 2 is negative 6. Negative 6 plus 3 is negative 3. Negative 3 times 2 is negative 6, plus 2 is negative 4. So now we also have the point 2, negative 4. So we will plot that point. Alright, and now notice we don't quite have this graph going back up. It certainly looks like we start down here on the left, and we're going up and then down, but we don't have it going back up yet. So that means that we need to keep going. So we're now going to plug in the point 3 and see what we get. So we'll drop down the 1. 1 times 3 is 3, plus negative 5 is negative 2. Negative 2 times 3 is negative 6, plus 3 is negative 3. Negative 3 times 3 is negative 9, plus 2 is negative 7. So now we can plot the point 3, negative 7. And notice that our graph is still treading downwards. So we need to keep going because we know it needs to turn back up. We know it needs to look like that. So now we'll plug 4 in. We'll drop down our 1. 1 times 4 is 4, plus negative 5 is negative 1. Negative 1 times 4 is negative 4, plus 3 is negative 1. Negative 1 times 4 is negative 4, plus 2 is negative 2. So now we have the point 4, negative 2. And now this looks good because this definitely is popping back up. We just need to make sure that we cross the x-axis as well. So we're going to plug one more in of 5. So we're going to drop down the 1. 1 times 5 is 5, plus negative 5 is 0. 0 times 5 is 0, plus 3 is 3. 3 times 5 is 15, plus 2 is 17, and that goes way off the graph, so now we can just finish graphing it by extending it upwards. So we made the table of values, and here is also our graph. So we're going to state our real zeros. Notice that we don't cross exactly anywhere. We can also see that by looking here at these y values. We never actually cross exactly. We don't get a 0 exactly. So here, our zeros, we're going to say occur between, and we're going to name the two x values that they occur between. So the zeros are going to occur between, we see right here when we cross, we're in between negative 1 and 0. So they occur between when x equals negative 1 and 0. We can also see that right here in our graph because we go from a negative number to a positive number, and that is in between negative 1 and 0. Our next one is here that occurs between when x equals 1 and 2. And once again, we can see that right here we go from a positive to a negative number, so in between 1 and 2. And then our very last one is over here. Now, my graph was not ideal, but it definitely is occurring here in between the 4 and the 5. So that's between x's 4 and 5. My graph should have looked a little bit more like that. Alright, so that's where the zeros occur between. So now we also are going to have to state the relative max and the relative min. So we're looking for peaks and values. So right here, this is a peak. So this would be a relative max. And this happens when x is 0. Here, this is a valley, so this would be a relative min. And this happens when x is equal to, that value was 3. and then our domain and range. So the domain here are the x values, and x can be any real numbers, and that's going to be pretty much the case for every single polynomial function that we see. And in this case, there is no absolute min or absolute max. We go up on the right and down on the left, so y will be any real numbers as well. Now a rule of thumb here is that if we have an odd graph, we're going to have real numbers for domain and range. When we have the even graphs, that's when we're going to have a restriction on the range. Now there's an additional example. If you'd like to listen to, or if you'd like to watch another example, tune into the part 2 of this video.